This is number 13 from section 10.2, and again we're trying to find, we've got the component form of the vector with a given magnitude, forms the given directional angle with a positive x-axis, so, and we want to find the component vector, the component form, so we'll draw a sketch. Now we're in degrees, so watch out for this. So this is 100 degrees. Well, this is 90, so this is going to go over here about 10. So this reference angle, or this reference triangle, is going to be, this is going to be an 80-degree angle. So that's what I'm really looking at. And my magnitude is 5. So I've got something like this. I'm looking for these sides of the triangle. So I can just use my right triangle trigonometry. This would be A, and this would be B. A is the horizontal component, B is the vertical component. We want to find A and B. And we know this is going to be negative because it's going in the negative direction. So if we, depending on what do you find for this triangle, this will be negative, that will be positive. So we can use our good old right triangular trigonometry, and we can say that let's find A, so that's the adjacent. So the cosine of 80 degrees equals the adjacent, which is A, over the hypotenuse, which is 5. And multiplying 5 times the cosine of 80 degrees will equal A. Oops, sorry. So we've got to get our calculator out for this one because it's not an exact angle. And I'm going to realize, first of all, that I'm in radians, so I'll take the mode. Where'd mode go? And I'll change it down from radians to degrees. And then I've got my equation over here, 5 cosine of 80 degrees. So I just say 5 times the cosine of 80 degrees. And I get 0.8682. And since it's going in the negative direction, it's going to be negative 0.8682, and that equals A. Okay. Now we want to find, so that's the A component for this, or A coordinate, or the X coordinate, the A coordinate. So if we want to find B, remember our vector V, if we call it vector V again, that's going to be A, B. What would be the corner of this point? I don't have much room there to put it there, so that's where we'll go. So now we want to find B, so sine of 80 degrees, don't forget it's degrees, equals the opposite over the hypotenuse. Over hypotenuse, so 5 times the sine of 80 degrees will equal B. So we put that in our calculator. We've still got the mode in degrees. I'm going to change that back afterwards because we're not going to usually work in degrees. And that's 4.9240. And that equals B, and that's positive because that's going up. So my vector will be like this. Negative 0.8682, comma, 4.924. There you go. Oops. Let's get it over so you can see it. And that's your vector component form. Okay, not too bad. Just have to kind of work it out, draw some sketches. Then number 15, same idea, find the component form of the vector. And pi over 4 radians is 45 degrees, so I'm just going to work it out with in degrees. We know we're just going to have an isosceles right triangle when we draw it, so let's draw it. Pi over 4, 45 is a nice diagonal there, yx. And since it's 45, we know that A and B will be the same. So we just have to find one, and this is going to be 3 times the square root of 2. So we could find B. We could just say the sine of 45 degrees equals the opposite, B, all over the hypotenuse, which is 3 times the square root of 2. And you can multiply both sides, so we got 3 times the square root of 2 times, and what's the sine of 45 degrees? Square root of 2 over 2. And that equals B, which is also A. Well, that's going to be 3 times, and square root of 2 times square root of 2 is 2 over 2, which is just 3. So that equals B, which also equals A. So these are both equal to 3. All right? So my component form is just that's all I got to do. Okay.